things, because again some concept is involved here. Read the question. Meanwhile, I'll construct the diagram. Read the question, and I shown diagram no, like that in your notes. You draw one diagram, then check what are all forces that are acting. What are all forces that are acting? And now we applied a force F. The force F I'll show by arrow, because this is the external force what we applied. What force we applied, that will be the tension. No? Go back to the laws of motion idea. No, that tension will act here. So is it no problem showing F like this, and the same F should act here. And what can happen to the block? What will happen to the disk? Look at the disk. Is it free to move? Is it the disk free to move? Yes, it is free to move. No. No. Will you put same F or different F? I said earlier, please do make observation. What is the disk? Having a mass, no? Mass of the disk is M. A disk of mass M and radius R. Here it is having a mass. There's a block. Now, will you put same F on either side of the string, because there's a string passing over it? No. Will you put FF there, or some other value? It should be tension. There's a mistake. What again students will do maximum. Huh? So therefore intentionally I'm showing that mistake what you're going to do here. The disk is having a mass, so therefore the tension on the either side of string must be different. And then because of force F and T is acting, how this will move? This will have acceleration A1 like this. Because of tension acting, how this block will move? It will move in this direction. Write all possible equation. Then we'll see what we can do. Is it okay, all of you? Assumption. And then F plus T should be equal to MA1. T should be equal to MA2. And there's a torque acting. F into R, T into R should be equal to, it's a disk, MR square by 2 into alpha. There's also alpha is there. Any constraint equation? So what should be the acceleration of this point P? Because acceleration of point P should be equal to acceleration of block. Why? Anybody? Why? Inextensible, no? String is inextensible. So on horizontal part of string, these two ends must have same acceleration. What is the acceleration of point P? R alpha minus A1. There should be equal to A2. It's all about observation, no concept. I'm telling this one. This will have, if center mass is having acceleration, all points will have acceleration. Sir, is it like that? Will you show what is the acceleration of this point? A1. Then it will have R alpha 1 like this, R alpha. I think I'll write R alpha 1. No. So what about acceleration of this point? What's the acceleration of Q? What is the acceleration of Q? Should be equal to A1 plus R alpha 1. Like that you can find out acceleration of any point, and what it should be the vector sum of acceleration of translative motion, acceleration due to rotative motion. So this is a constraint equation. R alpha 1 minus A1 should be equal to A2. I think here is what the students, what are the mistakes you do? Putting same F in both the strings. No, there's a mass. If massless, okay, this is having a mass. So there should be tension here. Then again, that constraint equation. Where all string comes, if the string is connected between the disk and blocks, whenever a string is connected between two rigid bodies, you should take help of the string to get the relation between acceleration. This idea, which you have to carry on in most of the numericals. Okay, rest all finish order. Once you are able to do this, you can manage other thing. He's asking acceleration of the block. I'll write the answer. You check it later on. So only I think the diagram showing all the things. Rest all you can write mathematics. So what students are doing is they are focusing more on this without assuming these things properly. Definitely, these are all anybody can write these equations. Not a fun. You must focus on what actually going on. How do they move? Once you know, once you show acceleration, all everything, no, then writing equations are very fundamental. This you know it. So please do put effort in a systematic way. So students are fighting with these things. This will come naturally when this diagram is correct. Please follow the method, systematic method. Okay, now similarly one more. So all these are small ideas. I think, yeah, this one. Because in books development, we just focused on pulley fixed all. So I'm just bringing a sketch of where the pulley is also mobile. A light thread has been tightly wrapped around a disk of mass and radius r. The disk has been placed on a smooth table lying flat as shown. This is a disk. I think the similar idea just now what I discussed.